friends, welcome to the channel. In today's video, I'm going to show you how to find the empirical formula and molecular formula in most exam style questions. I say most because these steps work, I want to say 90% of the time, and then the 10% of the time the exam boards decide to get a bit more creative. Now, if you want a copy of the question I will go through today so you can follow along, I will have a link down in the description below. So let's go. We will need three things to find the empirical formula: the mass of each element, their moles, and the mole ratio. So let's use this question to show you what I mean. One of the compounds in the table reacts with bromine to form G. A compound with the composition by mass of carbon of 22.2%, hydrogen of 3.7%, and bromine of 74.1%. Now part 1, show by calculation that the empirical formula of G is C2H4Br. Because this question literally states show by calculation, I know that this method that we're about to do will work for this. Alternatively, they could also say something like calculate the empirical formula of this compound, but we won't be doing that example today. Essentially, I will first write down this template. On the top, I will write down all the elements in the compound in a row. In this case, there's carbon, hydrogen, and bromine. Then, on the left of these elements, I will write down the mass, the moles, and the ratio in a column. Once I have these template down, I can go ahead with the question. Step 1, we need to look for the mass of each of the elements in the compound. They could give you this information in one of two forms. Either they could give you the actual mass, or they can give you the percentage of the masses. If they give you the actual masses, then great, just plug in those numbers and you're good to go. Alternatively, like in this question, they could also give you the percentages, in which case it's also not a problem. Just assume that there's 100 grams of the compound. Why 100? Because 22.2% of 100 grams is just 22.2 grams. One less thing for you to calculate. With that said, in this question, we have 22.2 grams of carbon, 3.7 grams of hydrogen, and 74.1 grams of bromine. Step 2. We need to find the amount of each of our elements in moles. This is where we will need the periodic table, as well as the equation, the number of moles is equal to mass divided by molar mass. Now, applying this equation to the question, let's start off with carbon first. We have 22.2 grams of carbon, and if we refer to the periodic table, it has a molar mass of 12. When we divide 22.2 by 12, we get 1.85. Then we can do the same thing to the other elements. So for hydrogen, we have 3.7 grams, and it has a molar mass of 1, so therefore we have 3.7 moles of hydrogen in our compound. Then for bromine, if we divide its mass, 74.1 grams, with its molar mass of 80, we get 0.92625. Whew, that was a long number. Step 3. We need to find the ratio between the elements in the compound. So we will need to take the elements with the smallest ratio and divide all of the elements with that number. So in this case, bromine has the smallest moles of 0.92625. When we divide all of the others by that, then we get 1.997, which is, we can round off to 2 for carbon, 3.994 for hydrogen, we can round off to 4, and 1 for bromine. This means that every molecule contains at least 2 carbons, 4 hydrogens, and 1 bromine atom. So it's safe to say the empirical formula is C2H4Br. And now we've answered the question, so job all done. Now, after finding the empirical formula, some questions will then ask you, find the compound's molecular formula. Or sometimes they just ask straight away, what is the molecular formula? To find the molecular formula, we will need two things: the molar mass of the empirical formula and the molar mass of the actual compound, which they will give. In this question, part 2 says the relative formula mass of G is 216. Deduce the molecular formula of G. So we found that the empirical formula was C2H4Br. This means that the molar mass can be found by doing 2 times 12 plus 4 times 1 plus 80, which gives us 108. Then, if I read the question, it says that the relative formula mass of G is actually 216. So, if I then compare the two molar masses, 108 and 216, I will see that the mole ratio is 1 to 2. If it's not obvious, then you can always divide them by the smaller number. Either way, Because the ratio between the empirical formula and the molecular formula is 1 to 2, then we know that the molecular formula has double the number of atoms of each element compared to your empirical formula. So because of that, we can say that the molecular formula is C4H8 and Br2. In summary, when determining the empirical formula of any compound, find the mass of each of the elements, then calculate their moles, and then you calculate the mole ratio between the elements. If you're trying to find the molecular formula, calculate the molar mass of its empirical formula, and find the ratio between the molar mass of the empirical formula and the molar mass of the compound which should be given. Then multiply the empirical formula by that ratio. I hope you found this video useful, and if you did, please like this video. If you have any questions or any content you would like to learn about, leave it in the comment section below. Hit that subscribe button if you'd like to see more of these videos. Thank you for watching the video, and I hope to see you next time. Bye!